design of this as I view on the left. Hello students, welcome to my YouTube channel VRacademy. Today's topic of discussion in digital electronics is clock signal and triggering methods. So because we know that these two are very important parts, because depending on that one we will try to understand different types of memory element in the future classes. So for that reason we have to know about this clock signal and its triggering method. So we'll start with the clock signal. Now what exactly clock signal is? So clock signal is a normal square waveform, or you can say it is a normal square signal which is having a fixed time period. I mean the time period of a signal is fixed and which is square in shape. Then that type of signal is known as clock signal. So the definition of clock signal is very obvious, that a type of signal which is square in shape and its time interval is fixed. That type of signal is known as clock signal. Graphically, when we are going for representation of any clock signal, it is represented like this one, as I have represented it over here by a simple square signal. We are representing the clock signal. Now after that we have to look for what are the various parameters that are present inside the clock signal, and those parameters we'll try to understand them one by one and we'll try to learn about that. Okay, so firstly I have drawn this one, and after drawing I have just mentioned this is the time interval that is called as t on, this is the time interval that is called as t off, and the whole summation of that t on and t off is nothing but total time period. And this is why this is called as time period, because after this interval of time, I mean starting from here till here, the signal starts repeating itself. Therefore this is your time period. Now we'll try to learn about each of these parameters one by one. What is t on? T on is time interval for which the signal remains in the higher state, or you can say signal remains at high, that is value, or you can say the value at that time is logic 1. Okay, so logic 1 for the time interval, the time interval for which the signal remains or signal value remains equal to logic 1, that time interval is known as t on. Similarly, the time interval for which the signal value remains equal to 0, or you can say for the time interval for which the signal remains at a low state, that is known as t off. Okay, now after that we have to what is t? What is the time period, or you can say what is fundamental time period? It is the time interval after which the signal starts repeating itself. This is the general definition that we have studied in the +2, that time period is nothing but it is the time interval after which the signal repeats itself. After knowing all these three parameters, there is next parameter that we have to know is frequency. Now from our childhood memories we know that frequency is nothing but it is the inverse of the time period. So frequency is equal to 1 by time period. The next parameter is duty cycle. This is new to you. What is duty cycle? It is defined as the ratio between t on to t. That means the time interval for which the signal remains in logic high state to the total time interval multiplied by 100. Duty cycle is generally calculated in percentage, or sometimes it is also calculated in fraction. That is also good, but here we are knowing it in terms of percentage. So duty cycle is nothing but it is the ratio of t on to t. And finally we know that in a general case, whenever we are going for representing any digital signal, we try to keep t on equals to half of the total time interval. Basically I am saying generally, we want in most of the cases, or wherever you are seeing the digital signal, you will be finding out that the time interval for which the signal remains high is just half the total time interval. So therefore I have shown it as t on is equal to t half. Now if you will be finding out the duty cycle, in that case you will be finding out it comes out to be 50%, or you can say it as 0.5. okay, 0.5. So this is all about the clock signal and their parameters. Now once again I am telling you, clock signal is nothing but a square signal with a fixed time interval. Graphically we can represent a clock signal by the square signal, where for the half of the time interval it will remain as t on, for the half of the time interval it will remain as t off. The total time period will be t. T on, it is the time interval for which the signal remains in logic 1 state, or you can say high state. T off is the time interval for which the signal remains in low state, or you can say logic 0 state. And what is the time period? Time period is the time interval after which the signal repeats itself. As we know, frequency is nothing but it is the inverse of the time period, and duty cycle is the ratio between t on to t. Okay, finally for a general case of digital electronics, we know that duty cycle comes out to be 50%. Why? Because T on is half of the time period. Now, once we are knowing about the clock signal, the next point of discussion is triggering. What exactly triggering is? So triggering is nothing but it is an event or condition. It is an event or condition at which the memory element changes its state. I mean to say, I'm giving you just a simple example. You just take an example of a switch, bistable switch. So if you are pressing on, your switch becomes on and light glows. If you are pressing it off, your light goes off and we are finding out no output. So such is the case. We are externally providing some force. That force is called as triggering in case of digital electronics. Externally, we are doing something in order to change the state of the memory element. That is called as triggering, which is explained or written over here. Now there are two types of triggering. One is edge triggering, the other one is level triggering. Edge triggering is further divided into positive edge triggering and negative edge triggering. This level triggering is also further divided as positive level triggering and negative level triggering. Now we will we'll go on understanding what exactly this edge, level, positive, negative, all these things I will let you understand with the help of a clock signal. Now this is a clock signal we have taken as an graphically. Now this part, I mean this one and this one are known as, these 2 points, or you can say these 2 lines are known as your edges of clock. Edges of clock signal. Edges of clock signal. Okay. So any device that operates at the edge of the clock, is called as edge triggered device. I mean to say, if any memory element will change its state at the edges of the clock signal, that is called as edge triggered device, changing the state at edges. Now, when we are going from logic 0 to logic 1, or you can say low to high, so the edge at which we are having the value at lower state and going to the higher state, that is called as positive edge. I mean to say, this edge will be called as positive edge. This is called as positive edge. If the signal value goes from low state to high state, or the clock signal value goes from low state to high state, that is called as positive edge. Similarly, when the value of the clock signal goes from logic 1 to logic 0, then that is called as negative edge. Okay, so any device which operate at positive edge is known as positively edge triggered. If any device which will operate at the negative edge of the clock signal, that is called as negative edge triggered device. Okay, now coming to the level. Now these points are called as, or not points, these lines are called as levels. This one is level and this one is also a level. Now this is your low level and this one is high level. Okay, high level. So when any kind of memory element which operate at high level, that is called as high level triggering, and the memory element which operate at low level is known as low level triggered device. So this is about positive edge triggering, negative edge triggering, positive level triggering, negative level triggering. Once again, I am telling you about the triggering. It is an event or the condition at which memory element changes its state. Means at any event or at any position, if or at any condition, if your memory element changes its state, that is called as triggering. There are 2 types of triggering: edge triggering, level triggering. Further division is positive edge triggering, negative edge triggering, positive level triggering, negative level triggering. What are edges? When the clock signal goes from low 0 value or low level to high level directly, so that is called as positive edge. When the clock signal drops from 1 to 0, then that is called as negative edge. Any device which operate at positive edge is known as positive edge triggered. Any memory element that operates at negative edge, that is called as negative edge triggered. These are called as your levels. This one is level high level, this one is low level. Any device which operate at this point, that is called as high level triggered device. Any device or any memory element which will operate at low level, that is called as low level triggered device. So I think it is clear to everyone. Now we clearly know about clock signal, we know about various types of triggering. So that is it about clock signal and the triggering methods present in digital electronics. If you have any doubt, you can ask me directly in my comment box, and if you have any kind of suggestion, you can come up with that. Your suggestion is highly recommendable. Thank you for joining.